Hey, today we're going to talk about the types of organic chemical reactions. You really only need to know how to do 3 of them, and you just have to be able to identify the last 2 types. For an addition reaction and substitution reaction, it's exactly like it sounds. An addition reaction, you have to start with a multiple bond, and what you're doing is you're either going to add a hydrogen or you're going to add a halogen, and you're going to break this bond. With substitution, it can be a single, double, or triple bond. So let's just show it. So we're going to add chlorine to this. And what you're going to get is you're going to break this double bond, and 1 chlorine is going to go onto each of the carbons. So you're actually going to get 1,2-dichloroethane. In other words, 1,2-dichloroethane. That is an addition reaction. You can also tell because this is C2H4, this is Cl2, and this is C2H4Cl2. You added everything together to get your product. We're going to do the same thing for our substitution reaction. Now this you could either add Cl2 or you could add, typically what they will do is they'll add HCl or Cl2. But basically you're going to pay attention to the final product. So in this one we're going to add Cl2 as well. And what you're left with is you're going to take off one of these hydrogens and you're going to substitute it with the chlorine. So basically you have H. You took off that hydrogen and you replaced it or substituted it with the chlorine. Now you're going to take that remaining hydrogen and it's going to add to that leftover chlorine, and you have HCl. Now esterification is a little bit more complicated, but all it really means is you're making an ester. So what you start with is an organic acid. In this case, we're going to do propanoic acid. And then you add it to an alcohol. In this case, we're going to use, let's use methanol. It's neater. So, what happens is you're going to remove, in fact, you're going to take the OH off of here, you're going to take the H off of there. Guess what H and OH make? It makes water. So you're going to pop that off, and you're going to be left with a methyl group. And then you're going to be left with this, this ester group, which is a COO. So that's going to, this is a reverse image now because I'm putting them together. I did not turn this one around, but I'm turning this one around 180 degrees. So I have the O, and then the C, and then the double bonded O, and then the C and the C. And the last thing I want to do is make sure I have my hydrogens. And again, just to refresh, wait, we also have waters left over. Now just to refresh, this is a methyl group. So this is methyl, and this is prop because there's 3. So it's methyl propanoate and water. And it's methanoic acid and, methanol and propanoic acid makes methyl propanoate. Now all you need to know, polymerization is when you take a lot of small molecules and you put them into a large molecule. A large molecule is called a polymer. So what would happen is you would take, typically what they will write is I've seen a question where they do things like this, where you will add an indeterminate amount, which is usually a large number, like 1,000 or more. You're going to add a large number of small molecules to get a big, giant chain. And this extends forever and ever and ever. Not forever, but a pretty long time. So basically polymerization, you're taking small molecules and making a really, really large one. And last thing is saponification, is you're making soap. Okay? Saponification makes soap. And the only thing you need to know about that is you start with an ester, you end with something else. If you're starting with an ester, it's saponification, you're making soap. If you end with an ester, it's esterification. You're making an ester. All right, good luck. You're going to do these practice problems.